Welcome back. Hope you had a nice break. Next up, we have Brian Fox, the co-founder and CTO of Sonatype, here to talk to us about the rise of next-gen software supply chain attacks. Really looking forward to this talk. And hey, Brian.
Hey there.
It is so nice to have you here. The floor is yours.
So a little bit of background on me. I started my career doing C, C++ development on public infrastructure, telephones, public health, those kinds of things. I moved into Java probably around 2002, 2003, and got involved in the Apache Maven build system not too long after that. I remain one of the PMC members and also a member of the Apache Software Foundation. In 2007, a couple of us founded Sonatype, and we've spent the last 13 years, 14 years working in this space, trying to help companies do a better job of managing what now everybody refers to as the software supply chain, especially for open source. Sonatype's also the company that runs the Maven central repository. We always have, and so I think that provides some unique visibility that I'm gonna reference as I talk through some of the things that have been going on over the past decade or so. So the first part, hopefully this isn't surprising to anybody, we're using a lot of open source software. For the last 10 years or so, any modern application is composed of at least 85 to 90% of open source. And you can see these download statistics here, they're huge, right? And the interesting thing is they continue to explode. This was statistics from last year around NPM, which is the JavaScript package manager that is most popular, and your typical hockey stick. Java is approaching 25 years old, but continues to explode in popularity. Last year, we served 345 billion downloads, and the early days of the company in Maven, if we were to show them on this chart, the long tail is so long, the numbers get so small that you can't even see them, just because of the explosion, right? And so this is generally a good thing. It allows us to build software faster and reuse components, but it comes with some challenges if not managed properly. Supply chains are everywhere, right? I think the unfortunate SolarWinds attacks that happened a couple of months ago have put this lexicon in everybody's vocabulary. But I think we should really dive into this and think carefully about what it means for software. The first kind of thing to think about is that we're not the first industry to face this challenge. And this is important to recognize because I think we as engineers like to creatively solve problems, but in a lot of cases we create more problems than we solve. And I think it's important to be able to look back and understand from other perspectives where these things can work. This one here, the Cobalt, Chevy Cobalt, what was this, back in 2013, 2014, was the kind of thing that happens in software all the time, but when it happens in the real world, people unfortunately die. They had a problem with the ignition switch. The engineers found it and fixed it, and they forgot to rev the version number of the switch. So when there was an investigation of reported problems, of course it was the classic works for me, not for you, works on my machine, not on your machine kind of problem, right? And it delayed the investigation. It made it harder to do the recall. They ended up having to recall all the switches. Most of them were probably good simply because there was no version number, right? So something that happens in the software world when it happens in the physical world has crazy implications. If we think the next kind of concept that happened along these lines, back when the 787 first launched, they had a rash of some battery problems, but because they had, in this instance, a good supply chain, they were able to quickly assess which lot, which manufacturer the affected batteries were coming from, and they fixed it rather quickly, and I think everybody pretty much forgets that this happened, right? It became a non-event because they had a good supply chain back then. And then, of course, remember a few years ago, it seemed like every season there was a new outbreak of E. coli happening with lettuce. And there was one in particular, this was 2018, where by the time people were getting sick, the growing season had moved from one part of the country to another. They weren't able to figure out which one was actually affected, very much like the ignition switch in the Chevy Cobalt. And so after several years of this, the growers finally got around to labeling their packages. So when the next outbreak occurs, instead of us literally having to throw out all the lettuce in the entire country, because we don't know where it came from, we can now target, when we know where the affected lettuce came from, we know which ones to get rid of, right? So these are basic supply chain practices that we all expect. DevOps likes to talk about Deming and the supply chain practices that he brought to Japan after World War I, right? So source parts from fewer and better suppliers, only use the highest quality parts, never pass defects downstream, and continuously track the location of every part. All right, so over the last decade or so, we've had multiple different phases that things have gone through. We've seen the early days where what I think everybody understands to be the classic problem, where there are vulnerabilities that exist inside of the software. People go to exploit them. This case here was the first struts vulnerability that existed. It was pretty much as bad as it could get. It was network exploitable, didn't require authentication. In fact, it happened in the core framework, so it didn't even matter what your code did. You were particularly exposed if you were just simply using this framework, and you didn't have anything else to protect you. It got so bad that the FBI had to issue alerts to their field agents, letting them know that people were being exploited. This was in the days of Anonymous, and there were a lot of banks that kind of had maintenance issues all at the same time. Not too long after that, you've got shell shock and heartbleed in 2014 that led to some notoriety because of the names and the logos that were applied to them. And then, of course, we get to a much broader one, Commons Collection. This was a vulnerability that was exploited to ransomware Hollywood Presbyterian Hospital in 2015. So they were taken offline for a week. And as we know, this probably killed people because lab results, tests, surgeries were delayed, all of these kinds of things. Then, of course, there's Equifax. It would be a great, great slide if you could see it. But the point being that these attacks happened just 2 days after the announcement of the vulnerability and the fix, right? So they were exploited because the bad actors found the zero-day report and then acted upon it faster than the updates were able to happen. This was basically the old story. If we think about the economics of cybercrime, there's some interesting statistics here that I like to share. In 2016, the whole worldwide global drug trade was worth $435 billion. Same year, the entire global cybercrime was already worth $450 billion. And when I first saw this, this was really profound for me, because if you stop and think about how much time is spent on the nightly news and things like that talking about drugs as compared to cybercrime, that was sort of an astonishing thing when you think about those two industries. And worse, cybercrime is projected to be about $6 trillion by the end of this year. Meanwhile, the drug trade relatively flat. The reason for this is, drugs are physical goods. It's harder to trade in illicit physical goods than it is to exploit digital resources and steal those kinds of things. So the second phase that happened were the attackers creating new opportunities. And this really started in 2017, where there was a report that found that the publishers of open source to NPM, 14% of them, 79,000 packages, were published. Those packages were published by people who had weak credentials that were easily dictionary compromised, or they had checked those credentials into GitHub, right? This was an astounding number, and it kind of just spoke to the lack of security maturity on the open source publishers. People tend to think about open source as being safe because it's people who know what they're doing, and the sad reality is today, with the democratization of open source via GitHub and the ease of publishing, that's just simply not true anymore. And so we saw fairly rapidly after that more exploits. So right after that, there was typosquatting in NPM, there was typosquatting in Python. And what I saw out of this was very profound for me was that the attacks, the things that were being put in there and typosquatted, weren't trying to exploit the end user product. They were trying to exploit the open source publishers. They were stealing more credentials, the tokens themselves used to publish to the repositories. And that was a profound escalation from my point of view. And so we used to talk about a lot of the details, but the years have passed. There's so many of these that you can't even, you'd need hours to diagnose every single one of these in a talk. But I'll share a link at the end where you can find more information. But these things continued to happen. Why is that happening? Well, like all engineers, they seek the most efficient path. If you look at this study here, the combined reach of the top 100 most influential maintainers on NPM cover nearly half of all the components in the repository. And if you look at the broad reach of the consumers of simply the top 5 packages, it's huge, right? So in terms of a force multiplier, of course, that's where you're going to spend your time. So you're looking at repositories in GitHub, where those projects get shared out to all of these different repositories, depending on the ecosystem they're in, and then ultimately get consumed by consumers. This is a massive way for anybody to distribute software, including the attackers who are after us. If we look at the trend, right? So starting in 2017, and we started tracking those over the first 2 years, there were 216 of them. So of course we could spend time diagnosing them in a talk. But then last year alone, it exploded 430%. The numbers this year, I don't even think we're going to be able to calculate them. And I'll go into some of the details in a few minutes here. But phase 3, this is the most important one, and the one that I want everybody to really remember out of this talk, is that what's happening right now is the attacks are focused on your developers and your development infrastructure, right? So a few years ago, there was an instance where Jenkins was attacked. This was an already fixed vulnerability. It was sort of your classic phase 1 type of thing, and it was attacked, and somebody used it to mint cryptocurrency, made some good coin there. What was it, last week, 2 weeks ago now, there was a breach. Probably not a lot of people heard of it, but Verkada, camera surveillance feed company, they were exploited by somebody getting in through their Jenkins system. That was found, of course, on Shodan. So this allowed the attackers to get access to camera feeds in schools, in prisons, in interrogation rooms, at police departments, hospitals, all kinds of stuff, right? And you've got to think that typical application security was focused a lot on the software that was being shipped, because that's what everybody's doing, and less focused on what's happening inside of development. And yet when the attackers get inside your development infrastructure, they're able to leverage that to expand beyond and go into other parts of the company. And so that's exactly what happened here just a couple of weeks ago. If we look at some of the key types of things that have happened over the past couple of years, we've seen instances where they're stealing NPM credentials, publishers. They're stealing passwords off of development systems, sending them to bad places in the world. They're stealing money via cryptocurrency or wallets. They're inserting backdoors onto the development infrastructure. Mid last year, we saw tool tampering, where there was a relatively unpublicized kind of a vulnerability that happened. It was called the Octopus scanner, and it had all the attributes that we remember from the early 90s XE viruses, where it replicated every time you ran it, it infected all the other XEs. That's exactly what happened in the development environment. So anybody using one of the affected components got a backdoor installed, and then it used the development infrastructure to replicate to all of the other components. So these are the things that are happening right now. If we look at what's happened over the last month, there was a pretty high profile thing, you might have heard of it, called dependency confusion or namespace confusion. There was a white hat hacker who collected a lot of bug bounties by showing companies how he was able to get into them. There were about 33, 35 companies that he exploited. And the way this works kind of looks like this. So on your development environment, typically you would have something like a repository manager, or even if you don't, you're going to have multiple repositories configured inside of your build. And so when your developers are asking for a component, let's say they want the latest React library, it's going to go to the repository and try to find the latest, right? So in this instance, it's already cached 3.1. It's going to find the latest and then get 5.2, and that's what's going to be returned back to the developer. Now, same thing happens for your internal libraries. So it's going to grab the internal library, the latest one, 1.3, right? Everything's working as designed. Well, in the dependency confusion space, what they're doing is they're going to the public repository, especially ones like NPM and Python that don't validate the namespace. Anybody can publish anything on any name that's not already claimed. So if they're able to figure out that you're using some internal library called R library, and they publish something R library in the public repo with a very high version number, the chances are that's actually the one that's going to end up in your build, right? And that's what dependency confusion is all about. And it's hard to manage this from a development infrastructure perspective, because things like NPM don't have a namespace. It's not like in Java and Maven where you can say, com.mycompany.star is all our internal stuff. You could see the names here are very flat. So how would you write a regular expression to be able to manage those things appropriately? It would be very difficult. And so what's interesting is, though, although that was a white hat attacker that launched that initially, we saw very rapidly lots of copycats. In the first wave of copycats, they of course were chasing additional bug bounties, but hiding amongst those were actual bad actors. And so we found some that were stealing bash history. And if you've ever typed a password on a command line on Linux, your password's sitting there in your bash history, as well as a lot of information about how your platform is structured, where your executables are and things like that. And they were also fetching Etsy Shadow, which has cached copies of passwords and things like this, as well as launching reverse shells, right? So it's one of these cases that even the white hat kind of announcements where they're trying to make it better, the copycats come and respond almost instantly. And so we saw an explosion of this, that the white hat kind of investigation occurred over 8 months in the beginning of the mid-20 to early 21. Within days, we saw 300 copycats. 72 hours, we saw 300 plus copycats. Within the following week, it had exploded by 7,000%, the number of packages we were tracking that had similar attributes. Most of those were white hat, but there were so many, it's actually impossible to identify. And then it took just about a week or so, 2 weeks, I guess, before we saw the malicious ones appear. I actually expected it to happen a little faster. And we stopped counting. There were 8,000, 10,000 copycats that were flooding not just NPM, but also Python. I think there were a couple that popped up. Just last week, we saw somebody was able to publish a component to the official list of Microsoft components. They have a page or something that references all of the official packages from Microsoft in the NuGet, and they were able to insert their random package onto that list and collect the bug bounty, right? So this problem generally exists across multiple dimensions of the ecosystem. It's not just limited to JavaScript. So what should we do about it? On the dependency confusion side, you need automation. You need some software that's able to help you understand how to protect against that. We added features to some of our products to help do that. If you're using a repository manager, you might be able to configure it to what we call routing rules or filter rules to make sure that it's not fetching your internal components from the public repo. But again, if you haven't used a namespace or named all of your stuff consistently, it may be very difficult using that base capability to actually manage those things. One thing you could do is you could go register your private dependencies or your namespaces before an adversary does. It happened to us. Somebody registered a package on NPM called Sonatype and tried to ship malware through it. So make sure you get your namespaces registered as quickly as you can. It will at least limit the scope. And we've been doing a lot of talking. I've been doing a lot trying to work with other package systems to kind of get them to think about doing namespace verification. It's something we've long done on Maven Central. You can't just show up on Maven Central and say, hey, I'm org.apache. We require validation of your DNS and some other things before you can publish under that. So at least on the Maven side of things, the ability for somebody to do a dependency confusion attack is much more limited because there is at least some validation, and we're trying to raise the bar across the ecosystem to make that happen more consistently. Now, some good news, bad news. We've been studying people for a long time, and these numbers used to be a lot worse, but focus on the red ones here. 50% have some process to manage a new dependency. 35% say they have automated tooling to be able to manage their dependencies. That's good news when you look at the survey that used to show that these were half those numbers. But if we bring this back to the part that we showed before, unfortunately I didn't get to see the slide so much, but with the Cobalt, Boeing, and the food supply, would we buy goods from companies where only half of their parts were validated and only 30% of them had any quality control? Would we get on those planes? Of course not, right? So why do we accept that from our software? I was having a conversation about this just yesterday, and somebody pointed out part of the problem is you can't see software. When you buy a car, you can feel the build quality of it. Does the door sound hollow, or does it sound like it's built well? It's very difficult for the average consumer, at least, to recognize good quality software versus bad quality software. And even in the case where software has a nice UI and looks like it's really well put together, it might be built on a house of cards of open source that nobody's paid attention to. And that's part of the challenges. So as we wrap up here, I want to leave you with some thoughts. You have a supply chain even if you're not managing it. I've seen companies be in complete denial. Not that long ago, companies were saying, we don't use any open source for our software. Meanwhile, they're downloading, hundreds of thousands of components from our central repository alone. And so they were in massive denial. So you have a supply chain, whether you recognize it or not. This is how your software is being built these days. The attackers are exploiting that fact that most people are not managing them appropriately, and they are now attacking upstream. And so if I told you about a new vulnerability right now, could you tell me, are you using this exact component in your software portfolio? Do you know which version of it? Do you know which applications are using it? Can you track the remediation of that across your portfolio? And how long would it take you to deploy and upgrade a fix to this? So many companies cannot answer these basic questions, right? And these go back to those things that Deming was teaching the auto manufacturers about, using better suppliers, using the best version of those, and tracking the things. It's what we expect our physical goods manufacturers to be able to do. Are you doing this in your software? Because if you're not, when the next thing happens, how are you going to respond? You can't even know if you're affected right away. How will you avoid the next malicious release? When the next thing gets either compromised, the publisher gets compromised, or there's a typo squad in there putting a backdoor into your development infrastructure. Do you have protections in place for this? Protecting your software is not going to, protecting the software you ship is not going to protect your infrastructure. So the way I like to hammer that home, again, using the Deming kind of analogy in the auto manufacturer here, those practices, the things we talk about in DevOps, DevSecOps, are designed to protect the software you're shipping. To either you're putting it into production or you're shipping it to end users. Doing all of those things will make better software. It will make you more efficient at that. But it's not going to protect the factory by itself. If your AppSec process is only looking at the software before it gets shipped, you've missed the war. Your development infrastructure, like Verkada, might be exploitable. Your developers might be downloading vulnerable, intentionally malicious components that are putting backdoors on their systems. That's not a great place to be. And so that's the thing that I want people to really take away from this, is revisit how you're approaching your application security and think about the ops security part of your development infrastructure as you do that. And lastly, last year, as part of the survey, some of the results I showed before, we kind of did a cluster analysis, and we put people in the 4 groups. top left are the groups that security runs the show. Everything must be approved by security before development can do anything. On the bottom right are kind of the polar opposite, where development runs the show and they can do whatever they want, security be damned. The top right are the companies that are doing both. And so what's interesting here is when you do the analysis, whoops, wrong direction, of the actual center of those things, what we found was kind of surprising, that even the companies who were just going as fast as they could, that was their main focus, is shipping software, doing updates as fast as they could. When they introduced best practice security practices, it actually made them faster, not slower. You could see that by the shift to the right. And so that seems really weird. Like, how is it that when we can do whatever we want, when we slow down and go a little bit more intentionally, how do we actually end up going faster? Well, how many times have you had to stop unexpectedly and go fix a vulnerability disclosure or in one of your dependencies, or even a valid security finding inside of your software? Those unplanned fixes have big impacts on your ability to deliver software. And so even companies who are doing a pretty good job of this can do better when you blend both of these together. And I think that's something people tend not to think. I think they tend to assume that, well, we might make it a little bit safer and the cost is going to come at throughput, that we're actually going to go slower to be safer. Our findings show that that's not the case in most of these companies. So that's I think a really interesting finding. If you want to find out more about that, if you want more details about the malware, you can get it at the URL at the bottom. And so at that, I'll stop and see if there are any questions.
Thank you so much for the talk and excellent recovery after the process switch. Apologies for the technicals. Yeah, that was okay. Very unfortunate.
Always got to keep you on your toes.
Yeah. I really like the point you made at the end, where it was actually the people who were moving faster and the high performers.
Yeah.
That was actually, like, when they introduced more security, they were moving even faster, and it doesn't slow you down. So if you feel that security is a hassle, just get started with it and do it correctly, and it'll help you along the way. So
I was surprised. I was like, are you guys sure that data is right? Because that just does not match what I expected you to say. And
exactly, right.
It was right.
Okay, so we have one question from Jacob. He mentions, any good resources for developers for learning how to prevent such attacks?
Well, I think starting with that supply chain report, because I think the details are too much to convey in a 30-minute talk, but understanding that you need to do a better job of choosing the dependencies, tracking the dependencies. It's a when, not if. People are going to make mistakes. The attackers for the last 3-4 years now have been very focused on this, and they're getting increasingly more sophisticated. And we're seeing it on the central side, that we're seeing people probing and trying to figure out how to get in. So far, it's been a little bit more difficult for them to do so because of some of the validation that I talked about, but I'm not going to stand up in there and say that it's impenetrable, but we're doing the best we can. And I think people just need to be aware of that. That's the thing that starts with. When you don't understand that this is what's happening, and you assume that all of the open source is trustworthy and that you can just use it and don't worry about it, that's where mistakes happen.
Yeah. Yes, I think the dependency confusion was super scary, because so we were talking about it at the office, a person shared an article, I read it, and I read it like it was written in 2016. And then I went back a couple of days later, I read it again, and then I looked at the date, and it was only a couple of days old. Yeah. So, but it was it just feels like a problem that had been there all the time, but
it was there. In fact,
discovered.
I was reading through the description of this new thing, that our researchers had kind of detected this through some of our malware and had reached out because it was clearly labeled as white hat. Yeah. So he kind of knew what was going on, and when I was kind of read into it, I was reading through it. And as it was like watching a horror movie that you've seen before, like, no, look around. And I was reading it, and I'm like, wait, I think I literally said this. And I went back in 2016, 2017, I think. Java Modules was considering how they would do some of the naming for the Java modules. And I had written a paper trying to get the committee to not make mistakes that NPM and Python had done and do that again in Java. And I use that literal example as a hypothetical example of what can happen when you don't have proper namespacing.
Yeah.
So I was like, I swear I wrote about this. Where did I write about this? And I was able to find it. And it's like, this is not new. Apparently, I wasn't smart enough to go after bug bounties with it, though, because that guy got $150,000 in bug bounties. That's some good coin. So yeah, some of these things are long-standing issues, and I think the point is we were lucky for a decade plus, 2 decades maybe, of the attackers largely ignoring this problem. Now they're coming at it and poking at all of these tools that we've used to become hyper-productive, and now we have to buckle down and fix them all up.
Yeah. Thank you very much, Brian,
Thanks, everyone.
for the talk.